So I just want to answer questions that you have on those book problems because I know that both of you were already working on them. And then tomorrow, instead of doing a Zoom, I think I'm just going to have a live video posted of how to do the work on
the YouTube.
Through YouTube of the new worksheet that I put into. Just so that you can work through it. I know the answers are already there. And then we'll
The answers are what? You have the answers?
Yeah, the answers are in that worksheet.
Oh, I didn't know that. I printed it out. What? Where are you going? Why?
Hi, Diana.
No. Mom knows.
She's connecting to audio.
Wait, can you hear us?
Yes.
Oh.
If you put your pictures on there, I could see you too.
I look pretty bad.
Yeah, I just woke up.
Yeah, yesterday Allison said she just rolled out of bed, so she was not going to put her face on there.
Yeah.
Okay. So what I'm going to do is I'm going to write on here, and hopefully it records everything. Again, we're just trying, but so I'm writing as Angela, but then I'm up here.
Yeah.
Yeah. All right. So in that book assignment, you had, I know that we had gone through a lot of the multiple choice and we had done a lot of work for the, we did a few of the free response, but are there certain ones that you guys would like to go over?
Oh, that's going to catch on fire.
I'd have to check.
And then I told them yesterday when I talked to them, and I don't know if Philippi has said anything about it or not, but the College Board is looking at alternatives. So let's say we don't get to go back to school and we're just doing e-learning and they don't want to get anybody together to take the AP test. How are they going to deal with that? Yeah, they're looking at doing it where you would do it at home online, I think.
Ooh.
Yeah, I heard about that.
Does that mean I can use my notes to take the AP test?
I have no idea. I would imagine that you're at home, so you can do whatever you wanted to. But for now, yeah, I think they're just looking at it. And then at 1:00 today, I have a meeting with other people at the school just to talk about what we're doing to support you guys while we're out.
You're like through like face-to-face or?
Well, no, just online stuff and how we're.
Oh, okay.
Because I think some teachers are doing more than others. I know, you know who's doing more than others. It's probably me and Philippi and Tippy and Mr. Porter.
This is the only class that I'm actually like doing work in, so.
Yeah, I appreciate it. It's kind of like we know that
because all my other teachers didn't assign work.
Yeah.
Like Lakes did, but it's like none of it's due until we get back, and it's all just like reading assignment, read a short story, answer questions. So.
Yep, and that makes it a lot easier.
Yeah.
But I know stats can be hard, and so I just want to make myself available for whatever we do. Before we go over I also wanted to say I got to go into the school today.
Ooh.
Because I had to go get a formula sheet for finite. But do you guys all have these workbooks at home?
Yeah.
Oh, yeah.
Okay. If you don't, then I could probably scan it. I have a scanner here at my house, and I could probably scan in some pages. But I think the week after spring break, we're going to kind of work out of this book more. And then maybe some other practice test questions, but I will probably use this.
Yeah.
Okay. So what can I help you with?
I have all the multiple choice, all the ones I didn't answer that I probably still have questions on.
Okay.
But I don't know which one to say.
Whichever one you want. I can be on here as long as you need me to, but I got to get off at 1 o'clock because I got to go to another Zoom meeting at 1.
What page is this on? 669.
While you're looking, you'll be happy to know I made some homemade crescent roll cinnamon rolls this morning.
Ooh. Were they good?
They were good. Yeah, they were. I put a whole lot of cinnamon in them. They were really good.
I don't have number 10. Oh, sorry.
Oh, go ahead. Go ahead.
I just said I don't have number 10 answered.
Okay.
Yeah.
So number 10 is, I've got the book right in front of me, so I'm just going to read what it says. So let X represent the outcome when a fair six-sided die is rolled. For this random variable, it tells us that the mean of X is 3.5. And this is number 10. And the standard deviation is 1.71. If the die is rolled 100 times, so what that means is n equals 100 times, n is known this time, then what is the approximate probability that the total score is at least 375? So probability that the score is greater than or equal to 375. So the it says that it is a random variable, and on your formula packet, you've got a couple formulas that go with that. It's a binomial random variable. We know how many times we're going to do this. So what we can say is that the if we know that we're going to do it 100 times and the average each time is 3.5, then to get the average overall, we're going to take the mean that's given times the number of times that we do it. And 3.5 times 100. Did I just type that in my calculator? I just did. It's been a rough week. And then to find the standard deviation of this overall, then our standard deviation is to take the, oh, that's the wrong one. Let me erase this. So we're going to do it 100 times. Remember, if we're just multiplying it by 100, then I should be able to take the standard deviation that I have and multiply it by 100. No, I think I might be lying to you. Let me type it in here and see if it's the right way. Don't write anything down yet. Squared times 100 square root. Okay, so it's going to be a little bit different in the way that we're going to do this. And remember the idea of the Pythagorean theorem for when we do the standard deviation? Yeah, because we're technically doing this, rolling this die 100 times. So each time it's going to have a standard deviation of 1.71. But when we are looking at it, right now we're saying the average score we would get is that 350. That's the average score overall. And then for the standard deviation, we would have to take the square root of the current standard deviation, re-square it to make the variance, and then we would add that to itself 100 times. So then we were going to take that times 100 to get the new standard deviation. So if we were just saying we were going to multiply by an amount of winnings, then we could do it. But because we're taking the actual sample size and adding it 100 times, it's like the first roll and then the second roll and then the third roll, then we have to look at it in this way. And so that gives us 17.1, where if you just multiplied them together, it would end up being 171, which means that your score could vary by a whole bunch instead of just by the little bit that it should.
Yeah.
When we do a probability. Yeah, because our standard deviations are usually pretty small compared to what the mean is. So if you get a big number, then you'll want to not, you'll want to think about maybe changing it to a different method.
Mm-hmm.
Okay, so we still haven't answered the question yet. The question is, what is the probability that a score would be greater than 375 given now that this is our new mean and this is our new standard deviation? So what I'm going to do is I'm going to do a normal CDF. I want it to be greater than 375, so I'm going to put in 375 as my lower. 350, oh, that's my mean. Go back. My upper, we'll make that something big like 10,000. And then my mean, I'll put in as 350. My standard deviation is 17.1. And then we can close that up. This is mean and this is standard deviation. And so because you just woke up, if you don't have your calculator in front of you, then we can do 375, 10,000, 350, and 17.1. And this probability will be 0.0719 approximately. And that is a little different than what the answer is on here, but you're going to pick the one that's the closest. And what does that round to? I think this is going to be C.
Yeah.
So what happens is if you did this by the formula and then you looked it up on the table, the chart that has all the probability stuff on it where the z-scores are, then you would get this number 0.0721 instead of 0.0719.
Okay.
And I feel like there's a lot of questions like this that can show up on the exam where they have a mean and a standard deviation given. You have to do some kind of transforming of it to make it work for the new situation. And then they have you do the normal CDF, which it seems like an awfully lot of work to do for a multiple choice question. But it is one that it does show up quite a bit.
Okay. So this is something we should kind of know how to do, or
Yeah.
at least practice more.
Yeah, I think so. And the more practice questions we do, the more you'll see it, and you'll get used to
Okay.
doing that. So, when we look at, so how could we describe this question? So it says it's a random variable first, and when we have a random variable to find the new mean, we can just take the mean times however many times we do it.
Yeah.
And then to find the standard deviation in the random variable situation, when they give you means, you have to square the standard deviation and then add it as many times as you need to. So sometimes it's just twice, sometimes it's 10 times. This time it was 100 times. And that's why we multiplied it by 100.
Okay.
And it all leads up to us being able to say that sample size is bigger than 30. And the rule is if the sample size is bigger than 30, so if n is greater than or equal to 30, then we can do that normality thing.
Oh yeah.
And normality means I can do normal CDF with it.
Okay.
Anybody else have a question? Diana,
I have
Diana
a
fell back.
question.
Yeah.
I have a question on 34 for free response.
Okay.
Yes, the truffles and nougat.
Number 34.
Yeah.
Oh yeah, and I'm taking a break from grading your AP questions. That's what we're supposed to be doing today. And they sent, since we're not doing it live, they sent me a bunch of videos, and each video is 30 minutes long.
Oh my.
So I have to watch the video and then grade a question, and then watch the next video and grade a question. But by the end of the day, I'll be done. It'll take a while though.
Oh my.
Okay, so 34 says, let's, I may turn my screen this way. That might be better. The candy shop assembles gift box that contain 8 chocolate truffles. So there's 8 chocolate, 2, is it caramel? Caramel.
Caramel.
The truffles have a mean weight. So the chocolate truffles have a mean weight of 2 ounces. So their mean is 2, and a standard deviation of 0.5. The nougats have a mean weight of 4 ounces and a standard deviation of 1 ounce. So the empty boxes weigh 3 ounces. So the box alone weighs 3 ounces, and the standard deviation is 0.2. So average weight 3, mean of 3, and then a standard deviation of 0.2. Assuming that the weights of the truffles, nougats, and boxes are independent, so one's weight doesn't affect the other's weight, what are the mean and standard deviation of the weight of a box of candy? So this is just like the one we did, where now though we have multiple means and multiple standard deviations. So for part A, to get the mean of all of them, we know that each box has, yeah, go ahead.
Oh, well, do you just add them then for
Yep.
the means?
Yep, we do.
And then then standard deviation, I forget what you do for that one, because you can't just add them together. I remember that.
So is that part B?
That's A, I think.
Oh,
mean
A and B,
standard.
okay. And then for the standard deviation, it would be the square root of, this is that Pythagorean identity or Pythagorean theorem thing, but because we have 3 pieces to it, we have to do each one. So we'll put in there 0.5 squared plus 1 squared plus 0.2 squared. But take all of their standard deviations and then square them back to variances, and then take the square root of them. And that should equal, I've got all the answers here, let me see, B. So oh no, I forgot one little detail. So it says that each truffle and each nougat has a weight of that. So if we're putting in 8 chocolates, then we need to multiply that by 8. If we're putting in 2 caramels or 2 nougats, we need to put a 2 into that one. And then the boxes are pretty standard. There's no changing those. So we need to make sure we include that.
Oh.
And then
How
on
would we
mean,
know?
yeah, go back up here to the mean too. So what I could do is I could say the mean of one box with 1 candy each would be 9 ounces. But what I've got to do is say that I'm putting 8 pieces in the box. I'm putting 2 pieces in the box, and then the +3 is just the box. I didn't read that clear enough. I thought we were just putting in that. So this will be 16 plus 8 plus 3, and that'll make that 27 ounces. And then this one will be 2.01 ounces.
Mm.
Can you see all of that screen?
Yeah.
Okay, so because every box has 8 of the one type and every box has 2 of the other type, and then it's just one box, then we have to make sure to do that. So then once we find this, on part B, it says, assuming that the weights of the truffles, nougats, and boxes are approximately normally distributed. So it's claiming the normality piece of that. What is the probability that a randomly selected box of candy will weigh more than 30 ounces? So then to do that one, we would have to do normal CDF. And it says more than 30. So 30. And this is for one box. So what is the probability that one box would be this way? Maybe we put in here 1,000. The average was 27 and the standard deviation was 2.01. Label that lower, upper, mean, and standard deviation to get full credit. And we end up with something close to this 0.0678 as a probability for that one box would weigh more than 30.
Do we do normal? So we do normal CDF when it says normally distributed, right? Then
Yeah. So if it says normally distributed and says what is the probability, that means to do normal CDF. Is that part okay?
Yeah.
Okay. And then on part C, it's asking if 5 gift boxes are randomly selected. So now we're going to think about getting 5 boxes. What is the probability that at least one of them will weigh more than 30? So we're looking at the probability that 5 boxes, at least one is greater than or equal to 30. So this one is a little bit trickier because we're going to use that idea of the complement that comes back, something that was pretty simple before. We're going to do 1 minus the probability that none of the 5 is greater than 30. And we know from above that the probability that a box would be more than 30 is 0.0678. So what would be the probability that a box would not be more than 30?
Do you you subtract it by 1.
Yep. So the probability that it's not more than 30 would be 0.9293.
9, yeah, 930.
9322. That's just for one box though. But we have 5, and we want to say that none of the 5 are. So I'm going to take 1 minus 0.9322. If it was just 1, it'd be that easy to do. But there are 5 of them. So we're going to take it to the 5th power.
Okay.
So and I guess this is just a rule of thumb too. If it says the probability of at least 1, then we always do the complement. We always do 1 minus the probability that none of them are.
Yeah.
Then D. D takes us back to that whole normal distribution thing again. So if 5 gift boxes are randomly selected, what is the probability that the mean weight of the 5 boxes will be more than 30 ounces? So we're choosing 5 boxes, and we're looking at the mean weight. So on your formula sheet, there's another formula that you can use here. And it says to find the mean of a sample, then we just keep the same mean that we had before. So the mean for 5 of them is the same as the mean for not 5. So the average would still be 27 ounces. And then to find the standard deviation, this is again on your formula sheet, then the standard deviation of 5 would be to take the standard deviation that we know to be true, that we found 2.01, and then it says divide by the square root of the sample size. So if we divide by the square root of our sample size, that's 5. And these are both on your formula sheet. And they're on the second page where it talks about formulas for proportions first and then for means second. And then once you have those 2 numbers, now you can go through and do the normal CDF again. So if we take 2.01, then divide that by the square root, we get something close to 0.899. And then I would do normal CDF. The lower is, what do we want? Greater than or equal to 30? More than 30. Okay, so we're gonna do 30. 1,000. The mean is still 27. And the standard deviation now though is changed. And it becomes this number here. And after you type that in your calculator, you'll get something pretty small, 0.0004.
So why are we doing normal CDF for this one?
So it's because the question started out on part B by us assuming that this was a normal distribution. Then when we find, so part C's probability is based on the one before, which is just a pretty straightforward probability. But then when we do the probability that 5 boxes would be more than 30 ounces, then we have to go back and make some kind of change. So let me add, is it okay if I switch screens?
Yeah.
Okay. So when we can have one sample, and we can say that that one sample standard deviation is 2.01. So if we drew this curve and we put 27 in the middle and we did our 3 deviations above and below, this one would be 20, I'm going to just do by 2s. It'll be about 29. This one will be 31. This will be 33. This will be 25, 23, and 21. Just leaving off that 0.01. When I take that one sample and say its average is in the middle here, and then it deviates by this much, this is how wide it is. The more samples I take, the bigger the N becomes, the smaller that distribution gets. The smaller it will get. Am I echoing again?
Yeah.
How did that happen?
Oh, there it is. Bad internet connection.
I guess. Is it gone now?
Yeah.
Yes.
It's too crazy. Okay, so if we take more samples, as N gets bigger, the variation gets smaller. So if I start to take more and more samples, let's say I take a sample of 5, so I have 5 samples this time, then the rule is that I need to take the original deviation and divide that by the square root of whatever that sample size is. What that's going to do now is it's going to shift this. It's going to keep the mean here in the middle, but it's going to make the deviation now shift from 27 to just that 0.899. So I'm adding just about 0.9 or 1 to this. So then this number is really going to become like 28, 29, and 30. This one's going to become 26, 25, and 24. So notice how it's technically like if I were to label them in real time, oh, that's the wrong one. Let me get rid of all these red guys again. So if I were to label these with a deviation of just 1, this one would be at 26, 27, and then 28. And this one would be 20. Wait a minute, I went the wrong way. You guys can't yell at me. 28. Okay, start over.
I am lemon grab.
I'm gonna figure it out. I'm not very good with these tools on here. Okay, so 27, 28, 29, and 30 would be 3 marks. Yes?
Mm-hmm.
And then I would go backwards, 26, 25, and 24. So now my bell curve is actually more like this than like that black one is. So notice that the deviation went from something that was this wide to now this wide.
So the bigger the sample, the smaller the deviation?
Yes. Yeah. So if I were to make this have a distribution where I took a sample of 100, then let's say that 100 is my sample size, then I would take 2.01 divided by the square root of 100. And that would be 2.01 divided by 10. And that's 0.2. So it shrinks it up even more. It still keeps the same center. That 27 is still the middle, but it pulls all of it makes that variation go away and pulls it closer and closer to the average. So ultimately we're saying like if we had enough samples, everyone would be very close to the average then. Everybody would be almost at the average. It will still become a normal distribution. It will still have that bell-shaped curve to it. And the more the sample is, the higher the sample is, the more bell-shaped it is. So you could take something that starts out as a skewed set of data, and eventually with the higher sample, it starts to pull everything in. And so it makes it become normal versus not normal. So it'd be like if you had this picture, and right now we know the mean is like right here. The mean gets pulled toward the skewness, and then the median would be right here. So if I start to take more and more samples, what happens is this median starts to shift over there so that eventually the mean and the median become the same thing. And then that creates a bell-shaped curve around it. And this is for higher sample sizes. In. Does that kind of make sense?
Yeah.
That's why
So
we like to say that the more samples we can take, the more the better. The more times that we can replicate something, the better it is.
So why in D did we have to do normal CDF though? Because it just asked for the probability of the mean weight. So why standard deviation? Is it because it was 5 gift boxes then? Is that what that means?
I think so, just because we are looking at the mean weight of it also.
Yeah.
On parts B, not B. So, okay, I understand why you, let me see if I can give you a better answer. So B, they definitely tell us like, that's why we need to do it. It's normally distributed. Let's find the probability. Part C and D are worded in the same way, right?
Yeah.
So I think that the main difference is on C, it does say at least one of them. And so at least one implies I need to use a probability for getting one of them, which would be part B. So I wouldn't have to do a normal CDF there because I've already calculated a number that I use for that one. But for D, we're looking at the probability that the overall weight of the box with the candies in it would be more than 30 ounces. So now we're back to that idea of we're looking at the entire box of candy, a mean weight for the box of candy, then means we're going to do normal CDF.
Okay. Yeah.
Like on part C, you could actually probably do like a binomial CDF kind of situation and still get the same answer for part C. But because it's talking specifically about a single box out of 5, then we wouldn't do it on that one, but we would on D because it's the mean weight of the boxes. I'm just going to try this and see. So binomial CDF is NPK. And then we know that we have 5 boxes. We have, it says at least one will weigh more than 30 ounces. So this one's kind of hard though because we don't know what P is. If we could figure out a way to get the P, then we'd be able to do it as a binomial CDF. But this time we don't. We'd have to put 0 here and then 1 minus it, but we don't know our proportions. Unless we use the probability from before, which was 0.0678. Let me try real quick. What did we get? Yeah, it would work. So this one, C is a binomial one just because they give you the number of times that you're going to do it. And then they say out of that number of times, so you have an N and you have a K. They tell you N and then we don't want it to happen at all. Then you could do it that way. But D, yeah, the only answer I can really give that works is that because this one is about a mean weight of the boxes as a whole group, as opposed to looking at them individually of the 5.
Yeah. Okay.
That, okay. Just let it set it. Yeah, let it set in and just think about it.
Where are you going to post this once it's recorded?
I do not know.
Okay.
I don't. I probably can put it on YouTube just as a private video for the people who have the link.
Okay.
Yeah.
All right. Because I have to go get my hair done. So.
Okay.
Okay.
Social distancing.
It's like gonna be me and like one other person.
Yeah. I went to Walgreens and picked up my allergy medication. That's why I wasn't available at 11.
Oh.
Did you wear your face mask?
I did not.
Corona.
They had tape on the floor though, so I had to stay 6 feet away from everybody else.
Wow.
Oof. All right. Goodbye.
Goodbye. Have a good day.
Goodbye.
You too.
Okay, ladies, what else? Is there anything else I can help you with? Are you done for now? What you want? I'm all yours.
I have like 2 more free response, but like I know how to do them, so I've just been looking at the questions. So I just actually need to write them down.
Okay.
I think. But 35 is long, kinda. Not really. It's 1 more extra question.
It's like, but it is like number 6. It's like the number 6 part.
Yeah.
Just has multiple parts for sure.
I don't know. I'm fine. Are you fine, Livia?
I don't really know how to do any free response.
Well, we have gone, I know we went through number 32. And now
I
we've
think
done
we went through.
34.
Yeah.
Did we do 33?
No, but I thought we did 31.
Oh, yes, we did. We did 31. Maybe we didn't do, I think we might have talked about 32 and how part B is just like 31. Because it's a hypothesis test, but we can go over whatever you want, Olivia. If you want me to do another one, I will.
Yeah, I don't really know which one. Wait, so which ones did you say we've done before?
I'm pretty sure we did
Already?
31,
Yeah.
and we may have done part of 33 together. I don't remember for sure. Where we talked about writing the least squares equation from it.
Yeah, I don't remember that. Yeah. I don't
So it doesn't matter. You
remember.
pick whatever. I'll go whatever you tell me. I could do 2 more and I could go really fast if you want. And then it'll be recorded and you can go back and watch it too if you need to.
Okay. Can we do 33?
Yeah.
Okay.
Okay. So this one gives you a whole lot of information. It's kind of like number 6 was on this mock exam that you took. And we're looking at information. We've got temperature and the distance to the nearest fish in the water. They give you the actual scatter plot. And then we get a computer output that has the values that we need for like R and R squared and other things that we'll be using. And then they give you the residual plot. And we want to write the equation of the least squares regression line and define any variables we use. So I know the 2 variables are temperature and distance. So I'm going to say that distance is what I'm predicting. So how far the fish is by looking at that table. And in that table, it says constant right under predictor. And then it says coefficient is negative 73.64. So that's my y-intercept. That's my constant value. That's what the distance would be if there was no, like if the temperature were 0, then we would say that they're like negative 73.64 distance to the nearest fish, which doesn't make any sense at all, but that's what it is. Then we would have to add the temperature slope. And it says temperature, and then its coefficient is 5.7188. And instead of putting X and Y, I like to put the words. So I'm just going to put in here temp. And then that would be my least squares regression line. I didn't have to define any variables because I wrote it in there. You could put X equals temperature and Y hat equals distance. If you would prefer to write them out like that, then that would be okay too.
Yeah.
And so that gets us those values. Then on part B, if we interpret the slope of the regression line in context, then what we're going to say is for each increase in, each increase of 1 degree, um, 1 degree of temperature, the predicted distance from the fish increases. My pen is not writing very well. Gosh. By about 5.7188. What was it? Inches? Meters. Meters. And so it's just like explaining slope, just like we would in algebra. And just saying that for every 1 degree of temperature increase, the predicted distance that the fish is will increase by about that much. Using words about and predicted usually are necessary.
Okay.
If you don't use the word predicted, they usually will knock it down to a P
Oh,
for that part of the response.
okay.
So predicted is important. And then for part C, is a linear model appropriate for describing the relationship between temperature and distance to the nearest fish? So we have a couple things to look at. We look at the scatter plot. We see that that's pretty linear. We look at the residual plot and we see that there's no pattern in the residuals. So I could say there's no pattern in the residuals. And what is R squared? So if I go back to the chart, I have S and then I have R squared. R squared is 94.5%. That's pretty high. So I could say no pattern in the residuals, and 94.5% of the variation in distance is accounted for by the line. So yes, those are the two reasons why. If it was like 50%, that probably wouldn't be good.
Okay, right.
Oh yeah, Miss Sellers.
Yeah.
So is the 3.5 banquet still happening?
As of right now, it is. But like I said, today we're having a meeting, and that's at 1 o'clock. And then I'll probably be able to give you more information after that.
Okay, because I was
yeah.
just like,
Yeah. As of right now, we are still supposed to be back to school by then. And if we are in school, then everything will go on as planned.
Okay.
But if we aren't,
well, yeah.
that's horrible.
Yeah, that's really horrible.
Really, it's making it. It'll make the end of the year so rough if that's what happens.
Yeah.
I don't know. We have like an extra like 2 weeks, don't we? Of like there's like because the governor said he gave us like 20 days or something like that.
Right.
I don't remember.
Yeah.
And we only used like 10 because there's
Right.
only because we got off too. So I don't know. But that would mean that there'd be only 4 weeks of school left for us.
I know. We definitely don't want graduation to be canceled. And if we can, I mean, any of your banquets that you're going to have, I would love to still have those banquets, but I'd rather us be safe and not, maybe we can move them later. Maybe, I don't know.
Yeah.
I don't know. I feel like for graduation, if they don't want all those people, then they can do what the basketball game did, like just have like intermediate family or whatnot. Just
right.
come.
Yeah.
And not like a whole bunch of aunts and uncles, because obviously, like, I don't know, some way, or if people can bring 2 parents or something. Like, I feel like canceling graduations, just there's so many other ways we can do that.
Yes.
And like, it doesn't really make sense on why the basketball game wasn't canceled, but our graduation might be canceled. Like, that doesn't really make sense to me.
Right. And
even though there's more people,
yeah, I think basketball, I mean, the game was postponed. I don't think that they've had it yet.
Oh, really?
Yeah, I don't think they had it.
Mm.
So, yeah, it'll be interesting. But yeah, hopefully after today, I'll be able to give you some more information.
Mm-hmm.
And I may just, if whatever we find out, I may just send an email to everybody who's on the 3.5 list and just say, yes, we're still on, or no, we're not. And then hopefully have plans for it.
Yeah.
Because I know Mrs. Davis said she wants prom to be rescheduled too. If we're back in school, she'd like to have prom still.
Yeah.
So we'll see. Okay, let me finish D. I'm gonna do it. All right, residual is y minus y hat. And y is from the original, and y hat is what we get when we use the predicted. So it says compute the residual for the point 2978, and then interpret it. So 29 is the x, 78 is the y. All we've got to do is figure out what is the y hat. So I'm going to use my equation that I had before. I had that y hat equals negative 73.64 plus 5.7188 and then I'm going to plug in that x from over there. And that will give me the y hat that I can use in my equation. Let me see if they have that answer here for me. Yes, y hat equals 92.21. And then for 92.21, we will put that in, we will put 78 in, and we'll subtract those. So I'm going to take 78 minus 92.21, and that is the residual. And that
Is
residual
it supposed to be negative?
It is. Because
Okay.
that means something. So what this means is if the answer is negative, that means that we remember that this is the observed and this is the predicted. So if the observed is lower than the prediction, then we will get a negative number, which means that the distance is over predicted because it's higher than the actual.
Oh, okay.
And so I would just add in here that it's over predicted by this linear regression. So negative number means over prediction. Positive number means under prediction. The writing is kind of like a little kid sometimes. Oh my gosh. That E is really big. Okay, is that all that? I think that's all for that one.
Yeah.
Okay. We did 34. Yeah, 35 just has a lot to it. I would look at 35, try it out, and then, you know, like always, just let me know if you have questions on it, and then I can go through those. But we'll take next week off since it's spring break, so no worries about that. If you want to keep working because you're home, then go for it. But I won't make you come on and do any videos or anything.
Did you post any assignments on Google on Unified?
There's one worksheet for I think the due date might be tomorrow.
Okay.
And it says let me see if I can, I'm gonna get off of here and see if I can do it. Hey, look at that.
Nice.
I'm learning. I really do hope that it's recording all this stuff, but I practiced yesterday and I finally got the sound figured out today. It was echoing so bad.
Yeah.
What happened? It won't let me sign in while I'm on here. Oh well. But if you go into if you go in there, then you will see that you have an assignment. I think it's that the due date is on is tomorrow, and then it has all the answers in it already,
Okay.
and you just have to work through. It's hypothesis testing or confidence intervals, one of the two. And I plan to make a video that you can watch for that that I'm going to post on YouTube tomorrow.
Okay.
And so we don't have to go live tomorrow at 11 if you guys don't want to, but I'll check in tomorrow and see if anybody wants to, and then I'll make myself available just in case you get a chance to try 35 and any other questions that you have.
Okay.
And then I keep on asking you, and I keep on forgetting. What's that AP Stats inference thing again? Like, what do we have to do exactly for that?
For the what?
It says AP Stats and inference. It's like an assignment.
That's where the worksheet is. Yeah, click on it, and then there should be a worksheet attached.
Oh, okay. And then wait, so do we just do it like on a regular sheet of paper?
Yeah,
And then
yeah,
just take a picture and stuff?
Yep.
Okay. Oh, okay. That makes more sense.
Okay. And then after break, I'll be posting some stuff about the workbook and what you can do in the workbook.
Okay.
Okay.
Okay. Anything else right now?
I don't think so.
I don't think so.
Okay. Thank you for getting up and joining me.
Yeah.
Someone had a joke earlier. I was supposed to share a math joke every day with my finite class, but I didn't do it. And so, do you guys know Cooper?
Yeah.
He posted one that said, why did the mathematician not go to the beach over spring break?
Why?
Because he had sine and cosine, so he could stay home and get a tan.
Oh my.
It was
That's
That's funny.
he said no one liked it.
Do all of your finite people usually come in the thing, the live?
Do they do what?
Do they usually like come in? Like, do they usually like join it, or do they like?
I've only been doing live video, not live videos, but recorded videos on YouTube for them.
Oh yeah.
But when we come back from spring break, hopefully we'll get a chance to do some of the live stuff.
Yeah.
Yeah.
Okay. Are you ready to take the AP test?
No.
Not quite.
I just messing with you. I'm messing with you. All right. Go do something fun for a little while.
Yeah.
Or take a nap, go back to sleep.
Have fun at your meeting, Miss Sellers.
I will.
Yeah.
I'm going to leave this one and take a quick walk around the house, and then I'm going to jump back on here and join with some teachers.
Nice.
All right. I'll see you guys later.
All right.
Bye.
Bye.